Today's video is sponsored by Coconut Monkey Electronics for custom handmade pickups in a variety of cool colors and materials and custom rewinds. Check out their website and take their perfect pickup quiz. And remember, when you support my sponsors, you support this channel, and I sure appreciate it. Hello everybody, Brad the Guitarologist here. In today's video, we're going to take a look at what I believe to be a 1964 or 65 Vox AC50. This is one of the later ones with the larger box. This was sent in by a watcher to the channel. What we're going to do is go through and do some general maintenance on the thing. We'll also try to sort of determine, I guess, as we go along, a little bit about the history of these Vox amplifiers, and if that sounds like something you'd be interested in, stick around. Here's the rear of the amplifiers. You can see the chassis faces upward on the rear. This thing was packaged really well, so I don't think this damage occurred during shipping, but there is a little bit of damage here on this corner protector. The plastic on it is cracked. That's the only real thing that stuck out to me that, you know, may have occurred, I suppose, during shipping. But I've seen a lot of these without these corner protectors on there at all, so that tells me they're probably fairly fragile. One of the things that kind of is frightening about these is that they actually put the primary voltage selector right up here on top, where anybody can just reach up and turn it. I mean, you could accidentally reach over here and think you're turning the volume or the bass or something, and say in the dark, and you know, if you're new to this amplifier, you might not know what you're doing and accidentally turn that. So that right there is kind of scary. This is a JMI era, produced in England. There were different companies in England that were manufacturing these for Jennings Musical Industries, or JMI. One of those, I believe, was a company called Triumph, and then there was another company that came later. This is going to be helpful kind of in our dating. As you can see, the serial number on this one's 3952. And they had different ones. Once again, some of them did not have this up here like this, and I would probably consider those superior, and at least in one way, not having that selector right up on top. But I think what they wanted to do with this, the reasoning for that was they wanted traveling musicians to be able to very easily just switch a selector, you know, no matter what country they were traveling to, and be able to take these around the world and perform anywhere they went easily. Let's go ahead and pop the back off this thing and get a look at the inside. Okay, so here is the rear of the amplifier, at least the back door, off. And we can glean a couple things here. First of all, I believe that this was added. That's this 1/4-inch jack. And this is also a American style 3-prong, which and it's relatively new looking, so I think, you know, definitely this has been put on later. Nothing else appears to have been changed, with the possible exception of this capacitor here. That one probably, yeah, that one's definitely, I'm sure, been changed. We'll get a little better look at everything in here and how these are put together and with what. Looks like a Mallory capacitor right there. I mean, that thing is old as dirt, and it's going to have to be removed. I totally understand the wish to open up something like this and to be able to document it and preserve the history of it, and to just get a sense of how it was built and the time that it was built, and, you know, how it left the factory, and all of these things. I get it. I understand that. But doing that at the expense of operability of the amp is just is a form of insanity. Frankly, I don't see very many Vox amplifiers. I'm in the middle of the United States. We don't have any real major cities close to us. You know, I live in Louisville, Kentucky, which is I guess the most major city in the state of Kentucky, but probably the closest large city besides Louisville would be Indianapolis, Cincinnati, So we do have some things close by, but I don't know how many Voxes would have been imported into these towns, as we had, you know, manufacturing coming out of Chicago that was flooding the market around here. So the market was pretty well satisfied with everything coming out of Chicago and Fenders coming out of California, and we had stuff coming out of the East Coast, and we had department store amplifiers, and there just wasn't a huge need, I don't think, to start importing Voxes, with the exception of the people who deliberately wanted to sound like the Beatles. You know, that probably would have been the only reason anyone would have paid the extra money to import a Vox amplifier when you had so many other options. Here's one thing I noticed right off the bat, and this may be part of the problem. The lead coming from the output over here to this terminal has come detached. But I wanted to show you this interesting way in which the cabinet is kind of put together here. You see a shelf here. Well, this, you just put your fingers in here and this whole thing slides out. The way that this comes out is rather cool. You can kind of see how easy it would be to pull some of these wires like that one, just because of how difficult it is to maneuver this thing around. Okay, so I've spoken to the customer about this Vox, and I told him about the wire that had come loose right here, and that could have been the source of his problems, because he was trying it in 8 ohms. There are 2 different taps here. This is a 16 ohm tap coming in here. This is an 8 ohm tap here. See, the ground is all broken off, and it should have been tied right there. So the ground wires is disconnected, and so is the 8 ohm tap. And he's actually trying to run it in 8 ohms, so it's completely disconnected. Anyway, we talked about that, and he understands that that was probably his problem. But I've also spoken to him about these electrolytic caps and convinced him that it's probably for the best, as long as I'm in here, to go ahead and replace these. These things are from the mid-1960s, and to leave these in here is just really playing Russian roulette with the amplifier. Also, he wanted me to replace these output tube sockets, because this one, for instance, sticks up above the plane of the chassis. It actually sticks up, I don't know, millimeter or so, and he wants to be able to use taller output tubes in these, because some of them touch the top of the amp. So he wants these sat down in the chassis a little bit further, but this one's mounted inset and this one is not. So we'll probably just go ahead and replace those with a pair of matching sockets, new sockets, and try to set them down in the chassis as far as we can. And there are a couple of other caps over here, and it looks like one of them may have been replaced at some stage in its life at least. Not sure what I should really be seeing in here. This one's from the UK, so that's probably original. This one, however, looks like a Sprague, and it might have been changed, but we will change those as well. Okay, first things first, I'm going to go ahead and change these larger capacitors. These are barely even tacked on there. There's not even much of a physical connection on these. So these capacitors are Hunt's capacitors, made in England. 16 microfarad at 450 volts on the red dot, and also 16 microfarad 450 volts on the yellow dot, so they're the exact same. Alright, so there are those larger electrolytics, and you can see what I've done here is I've used the old mounts. First I zip tied them together and then zip tied the pair to this thing, and they are in there very securely. So yeah, there's that part done. Now let's move on to this part over here, and we'll get this soldered in correctly, and then we'll come back and we'll do these smaller electrolytics up here on the board. Yeah, what caused these to break is just that this thing is so stiff that when you're shutting this up in the cabinet, this wants to kind of coil out because it has spring to it. So it's sort of pushing the wire back and forth when you do that, and it's putting some constant force on the connections, which we don't really need. So we're going to get rid of that. Alright, I found some wire that's going to be perfect. This wire I salvaged off of an old Hammond organ that I disassembled at one point. And this is good stranded wire. I think this was actually supplying power to one of the modules inside the organ. This is a power cord, piece of a power cord, and we're going to use this for the ground. I found that power cords are usually perfect for output cords. I've also gone ahead and made the wires. I'm going to make these wires just a little bit longer than they were initially, and that's going to allow the next tech who touches this to separate this piece from there a little bit further than they normally would have been able to. Okay, I really couldn't get this through the hole because it was a little bit thicker than the hole, so I've crimped it, I've wrapped it around and crimped it with my pliers, and now we will solder it on. You always want to try to get your best possible physical connection. Try not to just lay things up beside each other. I mean, it bears repeating. Always get a good physical connection, because that's going to be a stronger connection overall for longer term, and be much more reliable. So maybe this won't happen again. Okay, so there are our output connections soldered back on, and this is going to be much more reliable because we have some discrete wires that are more flexible than the original wire was. I think this cord is the reason why these connections broke in the first place. So, okay, so there we are with all of the smaller capacitors done. And they're all 25 microfarad with the exception of the one over here on the very end, which was a 50. Okay, so here's the rear of this Vox. We can see here we do have a couple of capacitors we're going to have to replace. We also have some really kind of cool older Tesla tubes you don't see all that much. Tesla tubes come from the Tesla factory, which was located in Czechoslovakia. 1994 is when all the equipment was relocated to the Slavic Republic. At that point, they became JJ tubes. So it's all the same equipment, but in a different factory, in a different country. But yeah, pretty neat to see some old Tesla tubes. So these are at least, what, 24 years old, something like that. Okay, these two capacitors ended up being on this side a daily, made in the UK. It has WJ here, which I think is a date code. Okay, through a little bit of research, I've ascertained that there were about 3 or 4 different versions of this amplifier, the AC50. This one, I believe, is a Mark III, also known as the AC50 OS/072 schematic, and this one is a solid state rectified version. The earlier ones had a GZ34, and according to this, there were about 5,000 or so of these amplifiers that were made beginning around January 1965. The values that we see here are 52 microfarad at 500 volts, and then a 32 microfarad at 500 volts. I don't know what the actual voltage is we see here. It says 460 right here on this point and 470 right there. So our normal 450 volt capacitors are not going to work in that position. Alright, I got a couple of F&T caps installed back here. I got a 47 on this side and a 33 on this side. It's odd that the 47 microfarad 500 volt F&T capacitor is actually smaller than its 33 microfarad counterpart, but that's just the way those are for some reason. I had to add a little bit of silicone to get this one to stay. Whenever that cures, that should hold that in place really nicely. This one was the right size, so it's not going any damn where. Okay, let's go ahead and get this this chassis here open at the bottom and pop these sockets out. Okay, on the bottom of this thing you have a piece of plywood with a couple of handle holes at the end, at each end, and you have 4 flathead screws. Okay, so I think what we'll go ahead and do is we'll replace these electrolytic capacitors here also. Oh, we've got some little Muller diodes in this. It's interesting. This will be the bridge rectifier right here, these 4 diodes, and then this one will be in the bias circuit. All these capacitors I'm going to go ahead and change while I'm in here. I don't know if I'm going to have a socket. See, because this is a bigger round socket. I've got another style as well. I've got these ceramic ones too, and they also are larger in diameter, and they won't fit in through the bottom. I'll tell you what though, this one will fit in through the bottom, but again it sticks up too far. I think what I might do, what I'm probably going to have to do actually, is put some shim spacers underneath here so that this sets down a little further. I'm thinking a couple of these might do the trick. It's pretty well there. I mean, that's way further down than it was, and that's about as low as you're going to get a socket to go, I think, on this. Okay, well, let's put everything back where it was. All right. So there's all that soldered back. Probably add a couple washers on this one as well and drop it down just a hair, which I may as well go ahead and do, and just get it as low as I can for him. Okay, so there are both of those sockets, and I think they're sitting down about the same depth now, so that's good. Let's go ahead and start on these capacitors. I'm going to need some oddball values. I need a 4 microfarad at 350 volts. There's an 8 microfarad at 150, and here's another 8 at 150. And I can use 10s in place of those. TCC Micro Pack. British made. Okay, so there are the electrolytics changed out on this board. And also there are the sockets with some shims in them to sink them a little bit deeper down in the chassis. Okay, one more thing I forgot to mention. There is a 0.05 capacitor right there, that big gray capacitor. That is the death cap. I don't think they had it in all of them, but they did have it for the American market. And this one up at the top has got a crack on it. I don't know if you're going to be able to see that or not, but there's a crack in the outer shell. Okay, here's the death cap out of this thing, and RS stands for radio spares, and there's their logo. It's 0.05 microfarad at 800 working volts, and you can see the cracks running throughout this thing. This is really cracked. Okay, we've got a new pair of Russian tungsols we're going to put in here that the customer sent along. Okay, we're going to bias this thing, and first thing we're going to do is measure these two resistors right here, because these two resistors on the end, these are actually cathode resistors on the output. So essentially this is a fixed bias amplifier, but there are 47 ohm cathode resistors, one on each tube. We're going to measure the real value of those first, and I've measured those out to 47, about 47.7 or 47.8 ohms. So we write that down on our paper. The next thing we want to do is fire up the amp slowly on a variac. We'll take a voltage drop measurement across each of these resistors, and then we will take a plate voltage measurement for each of the tubes, and we'll do some calculations and see where we are on the bias, see if we're within spec. If we are not, then we will adjust accordingly. Alright, so I have the amp hooked up to an 8 ohm speaker load just over here off camera, and let's go ahead and dial it up on the variac. Okay, there's 120 volts on the input. We're at 488 volts coming off the rectifier. 0.62 amps is what we're drawing. And I want to go ahead and check the voltage drop across this resistor. The voltage drop across one of them is 1.04 volts. And we'll do the voltage drop across the other one, and it is 0.89 volts. I want to check the plate voltages, and that one is 488 volts. Plate voltage on the other side is also 488 volts. 9.08. 10.6. So we're nowhere near what these are capable of handling. What I basically want to do is I want to raise the voltage drop. We'll try to raise it from 1.07. Let's try right there. Our resistance remains the same. We will measure our new plate voltage. 481. It dropped just a little bit. So 1.59 divided by 47.8 multiplied by 481. That's 15.99. It's basically 16 watts of plate dissipation on that one tube. Let's look at the specs for our EL34s, and that's a 6CA, should be a 6CA7. Yeah, here we go. 6CA7. Maximum plate dissipation is 25 watts. Okay, so what we want to do is we want to do 25 times 0.7. So we want to do 17.5 watts of plate dissipation per side. And right now, what did I say we were at? 16. So let's move it on up to 17. To really get the most out of this thing, we need to bias it right at 70% is where I like to be on something like this. When you dial up one side, the other side will change slightly, so you have to kind of go back and forth. Okay, there's 1.72. And there's 1.72 on that side. So we have perfectly balanced output. We have it balanced to 70% of the maximum plate dissipation, which is going to leave us enough room that when these tubes start conducting, when you're just jamming full bore, that they'll have enough room to go all the way up to peak. So yeah, I think this thing is ready. I don't hear any noises or anything like that at the output. It sounds really stable. So I think it's about time we button this thing back up, get it back in the cabinet, and give it a test. Okay, right now I'm going into the Brilliant channel, and we'll try that one out first. So that there was cranked about halfway on the volume, and it kind of seems to me like the tone controls are a bit interactive, and also this thing can go really buck wild if you're, I mean, it's almost like it's not getting a good ground connection or something. I don't know. I think it actually doesn't like my fluorescent lighting. I know that much. so that was the Brilliant channel. Let's move on to the normal channel now. Alright, so that is a 1965 Vox AC50 head. I hope you guys have enjoyed this video. If you have, please hit the subscribe button down below and also hit the bell to receive all notifications. And for now, y'all take care.